Good evening, students. Today's topic is carboxylic acids classification. So what are carboxylic acids? The organic compounds which contains COOH functional group, and how to classify them. So depending upon the number of COOH groups, we can classify the carboxylic acids. Monocarboxylic acids, dicarboxylic acids, and tricarboxylic acids. Mono has only one COOH group. Dicarboxylic acids have two COOH groups, and tricarboxylic acids will have three carboxylic acid groups. Are you able to understand this? So now, to write the structure of monocarboxylic acids, let us see the method. Take the number of carbons. So 1, 2, 3, 4, 5, 6. Now from here add 2, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14, 14 plus 2, 16, and then 18. So hope you have understood this. I am giving you the number of carbons here. So to write the monocarboxylic acids, we are taking number of carbons. Next step. So what will be the IUPAC name for this? When number of carbon is 1, you know that the root word is meth. Here it is eth, prop, bute, pent, hex. Next, 8, root word is oct. Next, dec, 12 is dodec, 14 is tetradec. You know, 4 is tetra, dec is 10. So 14 is tetradec. Similarly, hexadec and 18. So we know octadec. So octadec is nothing but 18. After writing this, simply mention AN plus oic acid, that is methanoic acid. Next comes ethanoic acid, and similarly propanoic acid, butanoic, pentanoic, hexanoic, octanoic acid, decanoic, dodecanoic acid, tetradecanoic, hexadecanoic, and octadecanoic. So using this method, we have written the IUPAC names. Next, how to write the common name? Common names are derived from the source or from the place, so it is easy to write. Now, for methanoic acid, you know, formic acid, then 2 carbons, acetic acid. Next, see, this is propanoic, anoic, but here it will become propionic. That is the difference between IUPAC name. AN will come here, here ION, propionic, and bute, N-butyric acid. So up to this is fine. Now to write the next carboxylic acids, we can use a simple shortcut method. So let me tell you that we can write like this: VC, left middle of principal's speech. A simple sentence: VC, Vice Chancellor, left middle of principal's speech. It's a meaningful sentence. Using this, write the first alphabets. So we can write it as V, then C. Here we have 3 C's here. Let me write 3 C's. After this, L, next M, and the P and S. So hope you have understood this. So V, triple C, L, M, P, S using VC left middle of principal's speech. Now What is V here? Valeric acid. This is caproic acid, OIC. Next, caprylic acid, YLIC. Next, capric, IC acid. So hope you are able to follow. So this is 5, this is 6 and 8 carbons. Next 10 carbons, 12, 14, 16, 18. For your convenience, I have written the number of carbons here. Later. Next, what is L? L is lauric acid. Next, myristic acid, palmitic acid, and stearic acid. Hope you are able to follow this. So, depending upon the number of carbons, we have written the common names. Next, what is the last step? The last step is to write the structure here. Using the number of carbons, we need to write the structure of monocarboxylic acids. So let us see. First one, only one COOH group and carbon is also one, so we can write it as HCOOH. Second one, COOH 1 and 1 carbon. See, later I will tell you how to write hydrogens. We can leave like this. It is easy to write. Next, so here we have totally 3 carbons, that is prop, and at the center you are having CH2 group, that is methylene group. So I have written 3. Next, write 4. For that, just add one more methylene group. So it is very easy. To the left, write carbon, and to the right, mention the carboxylic acids. Next, CH2 3 COH, that is 5 carbons. Pentanoic acid, valeric acid. Next, caproic. First increase the number. So we have 6 up to this. So 4. Completed. Later, the number has increased here. Instead of 7, you have 8, then even numbers 10. For that, again take CH2 and COOH. So, total number of carbons 8. Already 2 completed. Remaining we are having 6. So, mention the 6. Next structure is 8 COOH, because total number of carbons 10, at the center 8 methylene groups. What is the next structure? Write carbon at the right, left, and COH at the right. Then mention the methylene groups. Similarly, you can finish the structure of remaining monocarboxylic acids. So totally 16. Next, the last one is with 18. This is the structure. See, at the last you can mention CH3 here. So students, hope you have understood this. Using this method, we can write monocarboxylic acids. Next, coming to dicarboxylic acids. So again, we can use a simple method to write dicarboxylic acids. Let me take a sentence using OMSGA. O stands for oxalic acid. So first we are writing common names. M, malonic acid. S stands for succinic acid. G stands for glutaric acid, and A stands for adipic acid. So simply remember OMSGA and you can write the common names of the carboxylic acids. Next, what will be the structure? How to write the structure of this? First of all, dicarboxylic acids contain 2 COOH groups. So we have written this. Now coming to the second one. In between COOH groups, we can write one methylene group. So that will be the structure of malonic acid. Next. Earlier you had one methylene group, now you write two methylene groups. Very easy. First write a COOH groups, 2 COOH makes oxalic acid. Next, in between one methylene group makes malonic acid. Succinic acid you have 2 methylene groups. Similarly, 3 methylene groups you write. That will be glutaric acid. Now the last one, 4 methylene groups. So using this method, we can draw the structure of dicarboxylic acids. Now the last step, how do you write the IUPAC name for this? It is very easy, numbering will be done. You have 2 carbons here, therefore root word will become it. Suffix will be ANE, root word, suffix. Later, dioic acid. Oic acid is the suffix used for carboxylic acids, and di represents 2 COOH groups. Next, the structure of malonic acid. Again, give numbering. You are having 1, 2, 3. And carboxylic acid groups are at first and third position. So let us write down first root word prop. Next, suffix ANE hyphen 1, 3 dioic acid. Why we wrote 1, 3? Because at first position, third position you are having COOH groups. Similarly, here we have 2, 3 carbons and 4. 1, 4. Root word is but because 4 carbons. Suffix ANE. Next, 1, 4 dioic acid. Now the name for glutaric acid. So 1, 2, 3, 4 and 5. 1, 5. Root word is pent because 5 carbons. ANE suffix. 1, 5 dioic acid. Now the last one is adipic acid. Root word hex because 6 carbons are there. Suffix ANE. 1, 6 is the position. Dioic acid is the suffix. So hope you have understood this OMSGA, oxalic, malonic, succinic, glutaric and adipic. So first one write 2 COOH, then add 1 methylene group to each. So 1, next methylene 2, methylene 3 and methylene 4. Hope you have understood this. Now if number of COOH groups are 3, it is called as tricarboxylic acid. Let us see the structure. The last classification, that is tricarboxylic acids. We can discuss only 2 important tricarboxylic acids. First one, draw the structure like this. We have 3 COOH groups connected to the carbon. Now here CH2, H and CH2. This is called as tricarboxylic acid. Next, take 3 COOH groups. here it is CH2 and here it is CH2. But if OH group is connected here instead of H, this is called as citric acid. So now we have seen two important tricarboxylic acids. Hope you have understood the class. So in this class we have discussed about carboxylic acids and its classification. Next lecture we will discuss about preparation of carboxylic acids. Thank you so much.